So here's lesson 5, solving two-step equations. The thing that we want to know today is that when we solve a two-step equation, we need to identify the operations, and we're going to undo those operations using the inverse operations. We undo operations in the reverse order from the order of operations. So remember, the order of operations was parentheses, exponents, multiply and divide, and then add and subtract. So now we're going to start at adding and subtracting. Look for that first, then we'll look for multiplying and dividing, then exponents, and then parentheses. So in a two-step equation, over on the right here, we have multiplication, this 2x, 2 times x, so there's multiplication. And here we have addition. So we go over to our order of operations. I find this first. There is addition. So the inverse operation of addition, we're going to use subtraction to undo the addition. By that I mean we would end up subtracting 3 from both sides of the equation to keep this equation balanced. The second step, so that was step 1, so the second step is that we're going to use division, the division property of equality. We'll use that to undo the multiplication here of this 2x. So we would end up dividing both sides of the equation by 2. So let's go ahead and get right into this. Remember, when we do the order of operations, we're supposed to do this backwards when we're undoing the order of operations. So the first thing we look at in this example here is that we have a plus 3 and a divided by 4. So the first thing we're going to want to do is look over to our order of operations, and since I have addition going on, we're going to want to undo the addition. So the first thing I'm going to do is subtract 3 from both sides of my equation. Negative 8 minus 3 is negative 11, and I still have this x divided by 4, and plus 3 minus 3 is 0, so I used the additive property of equality, and I got rid of those 3's. So now the next step is, since I have division, I'm going to look back over here. Division comes next. Since I have division, I'm going to use its inverse, which is multiplication. And I'm going to multiply both sides by 4 to undo the division. Well, 4 times negative 11 is negative 44. And this ends up saying 4x over 4. And 4x over 4 is really 1, so negative 44 equals x. Can I check this? Sure. I would take negative 44 and put it in for x in the original equation. So I would have negative 8 equals negative 44 divided by 4 plus 3. So this tells me I have negative 8. Negative 44 divided by 4, order of operations, the normal way now, is going to be negative 11. I still have this plus 3. So negative 8 and negative 11 plus 3 equals negative 8. And so that checks. So my solution is correct. Let's try doing another two-step equation here. This negative 4x plus 3 equals negative 5. Again, I look for going backwards on my order of operations. So I have addition again. So we're going to need to use its inverse, which is subtraction. So I'm going to subtract 3 from both sides. Now, in case you're wondering why I'm not subtracting or adding 5 to both sides, the goal here is to always isolate the variable. So here's my variable. I want to get this all by itself. In order to do that, I'm removing all of the pieces from around it. So first I'm going to get rid of this minus 3 by subtracting it from both sides. Remember, it's an equation, so whatever I do to one side, I have to do to the other. Negative 4x equals negative 5 minus 3 is the same thing as negative 5 plus negative 3, which is negative 8. So here I have multiplication, so I will use the division property of equality and divide both sides by negative 4 to undo the multiplication. So negative 4 divided by negative 4 is a positive 1, so I just have x, or positive 1x. And a negative 8 divided by a negative 4 is a positive 2. Negative divided by negative is a positive. Let's check this, make sure that we did everything correct. I'm going to take my x equals 2. I'm going to stick it back into the original equation. So negative 4 times 2 plus 3 equals negative 5. Multiplication comes first. Negative 4 times 2 is negative 8 plus 3 equals negative 5. And negative 8 plus 3 is negative 5. So this, once again, checks. So another type of problem we'll have here is when there's two terms in the numerator of a fraction. Remember, the numerator is the top part. So x minus 7 here is the numerator. The bottom part we call the denominator. What you can see here is that this is still just division. So I have some term in the top, in the numerator, divided by some term in the bottom. Now we know that in order to undo division, what we have to do is multiply. So I'm simply going to multiply both sides of this equation by 3. When I multiply both sides by 3, what we end up getting is just the numerator by itself. These 3's, 3 over 3 is 1, so that leaves me with just x minus 7, and that equals negative 36. So that was one step. Now I can undo the subtraction using the inverse property of addition. So I will add 7 to both sides, and I get x equals negative 29. So again, can I check this? Sure. I take the negative 29, I put it in for x in the original equation. Negative 29 minus 7 is the same thing as negative 29 plus a negative 7. So that's negative 36 divided by 3 equals negative 12. And that is true. Negative 36 divided by 3 is negative 12. So this checks. What I really want to show you is what a fraction that has two pieces in the numerator, what that really looks like. So x minus 2 over 4 is really the same thing as having two fractions, x over 4 minus 2 over 4. Remember, when we add or subtract fractions, we have to have common denominators. And here we do. We both have a denominator of 4. And then, when we add or subtract fractions, all we do is add or subtract the numerators, the top numbers, and leave the denominator alone. So if I add or subtract the numerators, I would get x minus 2. I can't combine those. I don't know what x is. And I would leave the denominator alone. So as you see, x minus 2 over 4 is the same thing as 2 separate fractions. So let's see why things work the way they do here. If I break this into two fractions and say 6 equals x over 4 minus 2 over 4, and if I want to solve this equation, the first thing I would need to do, again, is go to my PEMDAS, my order of operations, and look backwards. So I find subtraction first. So the first thing I want to do is undo the subtraction. To undo the subtraction, I would have to use the additive inverse property here. So I would add 2/4 to both sides. And so this tells me I have 6 2/4 equals x over 4. The next thing I want to do is make this look a little bit nicer. This is really 2/4 is 1/2. So let's go ahead and call that 6.5, or 6.5 if you want, equals x over 4. This will be much simpler now. I can multiply both sides by 4 to undo the division. I have to use multiplication. And 4 times 6.5 is 26. And this is 4x over 4. 4 over 4 is really 1, so I have 26 equals x. So does this check? Let's see. I put 26 in the original equation for x, so I have 6 equals 26 minus 2 over 4. So 6 equals 24 over 4, and 24 over 4 is 6, so this checks. Now let's try doing it the way we did the first problem. So let me erase this. Now the way we did it the first time is I got rid of this division first. So to do that, I need to multiply both sides by 4. 4 times 6 is 24. And what happens here is 4 over 4 is 1. So I'm left with just x minus 2. To undo this subtraction here, I'm going to need to add. So I'm going to add 2 to both sides. And again, if you remember, I just get 26 equals x. So I don't know which way you like better. You're welcome to use either way, either method. But I think this method is a bit shorter. So I think it's important to know that x minus 2 all over 4 is the same thing as x over 4 minus 2 over 4. But using this method here that we just did is probably the most straightforward, simple way to do a problem like this. Alright, so now we want to learn how to use what's called deductive reasoning. Whenever you see deductive reasoning, it means you're going to be doing a proof type question where you're going to show each step along the way and give a reason why you're using that step. So the question is, what's the solution of negative 2t plus 7 equals 3? And then it says justify each step. Well, the justification, that's this reason part here. So the first thing we're going to do is we're always just going to write in the actual equation first in the steps. So the actual equation is negative 2t plus 7 equals 3. And whenever we do that, we call that step either given or original equation. All right. The next thing we're going to want to do is, in this case, we need to subtract 7 from both sides. Again, order of operations backwards. So we're going to need to subtract the 7 from both sides of this equation. So I have negative 2t plus 7, and then a minus 7. And that equals 3 minus 7. All right, and what we call this step is the subtraction property of equality. Let's clean this up, or what we call simplify. So I have negative 2t. Let me use I have negative 2t plus 7 minus 7 is 0. So there's nothing left there. And over here I have 3 minus 7, which is negative 4. So what did we do here? We cleaned it up, otherwise known as simplify. The next step is I want to take a look and see I have this multiplication happening here. So I'm going to want to take and use the division property of equality, divide both sides by negative 2. So I'm going to have a negative 2t, and that's going to equal negative 4, and I'm going to divide both sides by negative 2. And that is the division property of equality. Now once again, I'm going to just clean this up, make it look a little nicer. So negative 2t divided by negative 2, that's just t. And negative 4 divided by negative 2, well, that's 2. Once again, all I did there was simplify. So what did we do? We started with the original equation. We showed what our first step was, which was the subtraction property of equality. Then we simplified. Then we showed our next step, which was the division property of equality. And then again we simplified. And ultimately what we were looking for was the solution. So what is the solution? We found the solution. It was t equals 2. So that's everything for today. We're going to do a check your understanding again. Please put this on a separate sheet of paper. You're going to give it to me on your way into the classroom tomorrow. It's only 2 questions today. You don't need to show every reason here. You do not need to justify your steps like we just did in the previous problem, but you do need to solve these 2 questions. The 5x plus 12 equals negative 13. This is a 2-step equation. And also y minus 1 over 4 equals negative 2. That's also a 2-step equation. On number 2, you're welcome to do it either of the 2 ways that I've showed you. All right, good luck, have fun, and I will see you next class.